Hey everyone, welcome back. In this part we will configure Ingress and Metal Load Balancer to finally make our application work. We can build modified launcher and chat application, and to do so I will just copy the commands from README file which I prepared earlier. And once the image will be created, we will be able to build a Gonas launcher with the same approach. The idea is that when it creates a container, then it exports it again into the container D. Basically, I save it as a tar file and then import it in container D on the virtual machine where I have Kubernetes cluster. After that's done, I deploy the YAML files so I can access the launcher, and it can be seen in the get pods command. And when I access the launcher from the web browser, I will be able to see the rooms, and since we created admin page, I will be able also to access it, and from there I will be able to execute chat room. Basically it will create a chat room, and if I will reload the page, it will show in the interface. I can try to access it, but for now it will fail because we have not configured Ingress and Metal Load Balancer. Since for now I won't be able to remove the pod from the web interface, I can do it manually from the kubectl command. I'm also using grace period equals 0 and force parameters to make it quick, but I won't recommend to use these parameters in production since it can cause data loss and other issues. To configure Ingress, we could use again the commands from README, and once it's going to be deployed, we could look at the kubectl get services in order to see what services has been deployed. From there we will be able to find that the Ingress controller has been deployed and that it have cluster IP. We will use cluster IP to verify if our chat application works, because if we'll try to use localhost, it will return us 404. By changing the 127.0.0.7 to the cluster IP, we will be able to understand that the service actually is working. So again, if we'll use curl to resolve the page with the cluster IP instead of the localhost, the service will respond. And now we have the last part to configure. It's Metal Load Balancer to make sure that we can access the cluster from outside the virtual machine. Here is another subset of commands available in README which configure the Metal Load Balancer on the cluster. I simply copy-paste them into the terminal, and that would be it to configure the Metal Load Balancer. Aside of one small catch, that there should be a small file, YAML file, which should be modified according to the virtual machine IP address. This line represents the IP address which Metal Load Balancer will use so we can access from outside virtual machine the service. Before deploying the YAML file, let's see what we have in the Kubernetes cluster. Pods are running and we also have services, but neither of them have the external IP address. After deploying the Metal Load Balancer YAML file, we will see that the external IP will be assigned to one of the services. This will be done immediately after deploying the Metal Load Balancer. Getting the service status after deploying the Metal Load Balancer, we can see that the external load balancer has been accessed to HTTP service. To quickly fix this issue, neglecting any best practices since it's our MVP, we can access the service which have IP address assigned and change the load balancer to the cluster IP. This is a quick fix. Again, don't do this in production, but for our MVP this works. And after checking the services again, the IP address has been assigned to Ingress Nginx controller, and this is what we actually expect to have. Now let's get back to the web browser and verify if the service works. The service opens, chat room works, and if we will open another page for the chat room and put it side by side, we can verify that the chat actually is working and we can communicate between two different sessions. By typing some messages, They will be sent to the Go chat application using WebSockets, and it will broadcast it to all the clients which are connected. We can also shut down the service. This can be done by using the delete button. When delete button is going to be clicked, we will receive shutdown message in chat window. Usually it takes only a few seconds for services to be removed, but in my case I had to redeploy the entire container since I was using old Kubernetes config from the another virtual machine which I already deleted. This is something you can verify along any other checks if you'll have any issues. But that's it for now. The application works, and thank you for watching.